The broadcast is now starting. All attendees are in listen-only mode.
Hello, good morning. This is Sugalya Murugesan from ZSL. Welcome to the webinar, Making the Move to Cloud, Things to Consider. The speaker for today's session is Naveen Noel, Senior Enterprise Solution Architect, Idea Lab at ZSL. Naveen will discuss on different types of cloud infrastructure, cloud hosting types, deployment scenarios, comparative study between traditional versus cloud hosting, key factors to consider while migrating to cloud, which apps to go on the cloud, and its benefits and few success stories. During the presentation, all participants will be muted. You can submit your questions on the right-hand side of the screen using the chat window. We'll answer some of the questions during the Q&A session that follows the presentation and answer any questions offline. So today's presentation will be recorded and posted to the ZSL's TV and webinar page. With that, I would like to turn the presentation over to Naveen. Welcome, Naveen.
Yeah, hi Sugalya. Thank you very much for giving me this opportunity to speak about the cloud and its various uses. Yeah, so here I'll be talking about making a move to the cloud and the things to consider when you're making this move. It's going to be mainly focused on hosting and converting applications from traditional hosting onto the cloud platform. What are the differences? So we'll be seeing some of those points here. So the session objectives would be generally introduction to ZSL and what's my role in ZSL, what is cloud computing, essential characteristics of cloud computing, and cloud service models, the deployment types, taxonomy, the cloud hosting side, so the different types of hosting in the cloud and what are the benefits of cloud hosting, so what applications can we put on the cloud. I know there's a lot of content. I'll try to cover it as soon as possible. Let's see how this goes. And at last we covered the case studies and some of the services what ZSL offers. So about ZSL. ZSL was founded in 1999 with a background in providing IT consulting. We are 15 plus years a global technology integrator. We have a state-of-the-art research and development centers in India and US. We are 4,200 employees totally. We have the Get IT Together partnerships. We have emerging technologies. And we specialize in that, especially the technologies very vendor-focused and aligned. And we're the pioneer in industry solutions development. So we can get all this information on the ZSL website itself. So my role at ZSL. Oh, I think there's some technical difficulty. Let me just check this. Are you able to view my screen?
Yes, Naveen, we are able to view your screen.
So you're able to see my role at ZSL? All right. Can you see that?
Yes.
Yeah. So sorry about that glitch. So I work out of the Edison office. I'm a practice lead for enterprise computing. I handle the cloud application development and cloud hosting, the pre-sales, and we can bring in new clients, and we focused on new value-added R&D, product development, and product engineering services. I've been working on the cloud technology since the early 2007. So what are the essential characteristics of cloud computing? So I'm not going to discuss about what is cloud computing because already everybody knows this. The audience, most of them will definitely know what is cloud computing. I would like to just touch briefly upon the essential characteristics. So the on-demand self-service is one of the characteristics. So we have ready-to-use services, minimal intervention from the provider. So everything is ready, available, it's on demand, there is no intervention from the provider. So in traditional hosting, you have to call them and they will put up a system for you. You have to basically have some human interaction. In the cloud model, there's no minimal intervention from the provider. So you have a broader network access. You can access a wide area of network services. All are virtualized, so it's all at your disposal. You can use them with minimal, very easily. The resource pooling. So you can pool resources on demand, like compute, memory, storage. All these resources can be pooled whenever you want, and they can be released whenever you want. So the cloud has also got rapid elasticity. You can scale up, down, out, scale out, scale in, scale up, scale down with on demand. So you can increase the number of instances. You can increase the CPU and RAM on demand. So it's also got measured service, where you have metered usage and billing, where you actually can see which are the services you've consumed, what are you paying for each of these services, and CapEx versus the OpEx versus the CapEx. That's what it essentially means. So you only pay for what you use. And the other benefit of one of the cloud is multi-tenancy. This is basically seen in software as a service clouds, not so much on the infrastructure as a service. Usually they share the platforms. They build software as a service modules and share it with multiple clients. The clients do not know, or the cloud providers' clients do not know that it's being shared from one common platform or one common server. That's how the software as a service model. Multi-tenancy, that's how what multi-tenancy is. Of course, on the infrastructure as a service layer also, they share the same virtual physical box with multiple users. Say they have 4 or 5 virtual machines running on it. That also is possible. So cloud service models. So what are the different cloud service models? At the bottom level, you have the infrastructure as a service, where everything is virtualized. You have a server, you have a network, you have OS, the operating system, you have related resources like firewalls, software firewalls, storage, network, servers, CPU, RAM, all this come under the infrastructure layer. So target are basically ISVs, developers, IT organizations. Example would be Amazon's Elastic Compute Cloud. Of course, the EC2 right now is slowly moving towards kind of a platform as a service, but they started off with infrastructure as a service, where they give you everything as infrastructure components, and you got to assemble and use it the way you want to use it. So the other examples are OpSource, Rackspace, GoGrid. All these clouds are basically infrastructure as a service. IBM Smart Cloud Enterprise is slowly moving towards platform as a service. They have a platform component as well. So next type of clouds are the platform as a service cloud. These clouds build over the infrastructure as a service clouds. So they need to have an infrastructure as a service layer underneath that, and then they build a platform over that. So what is the difference? I mean, what is the platform as a service? What do they have? They have middleware services like database, application frameworks, like for example, JBoss, MySQL, say Tomcat, and say SQL Server. All these services are as a service, delivered as a service over the web. So essentially, you don't have to worry about how much a scale is there, and if your users hit the threshold, you have to go and scale up instances and make sure that everything is all right. So all the platform guys take care of all these things for you behind the scenes. So the infrastructure guys just provide you with the infrastructure, and it is left up to you to actually scale that up, scale that down, and manage that. But in the platform layer, they manage all the plumbing behind it, and you only have to worry about the application and your business logic and the business process. So essentially, in the platform as a service, you need to upload your application, you need to upload your runtime, you need to upload your database files, all that onto a platform, and then they take care of running it for you. So typical platform guys are Google. Is one of the very popular platform as a service, Google App Engine. Azure is one of the clouds which is competing with Amazon. They are more platform driven. Force.com is also the Salesforce. That's a platform, very big platform for developing applications. And relational database service from Amazon, that is also delivered as a service. We also have our IBM Smart Cloud Enterprise. And to top it all, we have many guys coming out like Nodejitsu and Heroku, and so many of them are available. And in fact, Heroku is built over the Amazon platform. So Heroku is a very popular platform as a service vendor, and they have built this whole platform over the Amazon's cloud. So the infrastructure cloud, just to give you an example how they fit in. Then we have the third type of cloud, that is the software as a service cloud, where services and applications served are served from the internet, totally end users, and You don't have to upload any software. You don't have to upload anything. It's a service delivered over the web itself. So the software itself is delivered over the web. So Salesforce.com, Hotmail, Google Docs, Constant Contact, all these softwares delivered over the web all fall under the software as a service. So you don't have any place to upload your own code base or upload your own binaries. So the infrastructure, let's wrap it up. Infrastructure basically is the bottommost layer. They give you the infrastructure for you. You manage everything right from the platform and the software. The platform layer, the guys, they give you the platform, and the software as a service layer, they give you even the software also. You just have to log in and register, and then you're done. So that's the 3 different models. So we have different types of cloud deployment types itself. We have the public, private, hybrid, and community. Very quickly, the public cloud is available to public. Anybody can use this cloud and provision anything what they want. So we also have the private cloud. The private cloud is built as a cloud inside an organization behind the firewall. So the cloud is, maybe some parts of the private cloud are probably exposed or something, but the concept is behind the firewall so that all their private IPs. So it's the same cloud built inside the traditional the network. We also have the hybrid cloud, which is a combination of the above 2, where you have partly public, partly private. For example, some databases and all that are private in the private cloud, and then the public cloud, all the web-facing apps go onto that. The last, we have the community cloud, which is shared by similar organizations and for mutual benefit, where they have a cloud, and only certain organizations have access to it. So basically, community clouds are usually public clouds, but kind of a virtual private cloud, community cloud kind of a thing. So it is on the web, but you cannot access it. It's only for certain organizations. Typical examples would be governments, universities. These are the guys. So that is the community cloud. So the cloud taxonomy, in fact, the slide explains everything what I just explained to you in the previous 2 slides back about the infrastructure as a service, platform as a service, and software as a service. It's just a visual representation of what you manage and what you don't manage. So in the traditional IT, you got to manage everything. You got to take care of everything. So if you have a traditional IT, you have your own data center. You got to take care of everything, right from the networking up to the applications. In infrastructure as a service cloud, your networking, storage, servers, virtualization, everything is taken care by the vendor itself, and you only focus on the operating system, the middleware, the runtime, basically runtime of your application, the data, and then all your other applications what you have to install. And in the platform as a service, the OS, the operating system, the middleware, and the runtime, all these 3 are also taken care of by the platform guys. As I was explaining, the applications and data, that is your thing. So the database and your applications, your binaries all have to be uploaded, and they take care of everything right from the runtime to the networking, and they scale up, scale down as per your need. So the software as a service, applications, all the things are taken care of by the software guys. You don't basically own any application. There's some kind of a controversy on the data. So basically data, they take care of it, but you own the data. So that's the only component which you own. So what I mean is, if you upload a database, you have your database residing on the cloud somewhere. So that data is yours, and they take extreme precaution security measures to protect that data from anyone. And that is your property. But the application itself is basically given by the vendor. Like for example, Salesforce, they give you the entire application, and you just have to register, log in, and then you start creating your apps, or and using the default features. You want to extend it, you can extend it. And then the database, whatever is there behind this backing up your CRM, whatever application you have, is your data. So they manage the data, but the ownership is yours. That's what I wanted to say. So what is the difference? What is the traditional data center? So dedicated and owned, basically, to make it very simple. So typically, you would have the internet. You would have some edge routers. It would come through a firewall. It goes to the local area network, and you have all your web server, your file servers, mail servers, app servers, whatever, all of them. And then typically, you would have a private subnet where you have another firewall, and you have your database servers behind that firewall. This is not the ultimate setup, but definitely this is a kind of a way how usually IT shops or organizations are deployed. So the physical hardware totally owned by you, the control, you have complete control of every single piece of hardware here and software here. So it is very capital intensive. So you basically require more people to manage this data center, and anything goes down, you need to physically take care of everything. There's no third party or vendor involved in this process. So resources, the compute, storage, network, building block, assembly is still required. So you get all the resources, you still have to fix them together, link them together. The vendors basically, if you go to a traditional data center, they will give you the space and you have to fix everything by yourselves. Utilization, resources may be underutilized, but you still pay for it. So for example, you just see we have 2 web servers in this diagram, and the load is say is 100 users or something logged in, and the one web server is being used, but the other web server is idle. Yes, I understand. Sometimes both the web servers need to be loaded up because during the day, the load goes up from 100 users, say, to 1,000 users or 200, 300, whatever will be the number. So that time the web servers are being used extensively. But during the night, when there's no load, only one web server is used and the other one is idle, but you are still paying for the power, for the hardware. If you leased it out for the lease itself. So everything is being paid for there. So performance issues may negatively affect the user base. So that is also another condition in the, performance issues will be there, and it may negatively affect it. So because you cannot scale just randomly how you want, you have a limited capacity there. So if I want to go, say, the example from 1,000 users to 10,000, 1 million users, I just cannot randomly scale 2 web servers or have under 10 web servers attached to the cluster there. It's not that simple. It has to be provisioned. It takes a couple of days to do that. So hardware provisioning required, or as I said, it always takes time. It's not self-service. Users have to request for resources and the vendor has to provision them, and it goes for a couple of days. Nowadays, recently, these vendors have improved, and from weeks together, they have come down to days, but it's still days. It's not the cloud. Cloud is in minutes. So scalability, it's not scalable instantly, as I just explained. You do have problems when you want to scale on the spot, instant scale. So fixing takes time. If one of the Tomcat or MySQL servers go down, it takes time to reprovision and fix the existing server. So suppose the web server goes down, you need to find out what the problem is, either fix it or get a new server and attach it to the cluster. If you get a new server, it means you're buying new hardware. If you want to fix it, that means you're actually having downtime. So it's like, a give and take. So we choose dedicated servers when you know your load is a load and when there is no big variations in traffic. So we choose dedicated servers and manage them that way. So this is typically a traditional data center if you own it and it's dedicated to some specific application. So let's see the hosted co-located data center. So you basically have, this is the middle one. You have a virtualization layer. You have no upfront investment. So in the diagram, if you just see this, you have 2 users coming in, different groups of users. They go through edge routers. They come to the firewall. You have a local area network, and you have something called as the virtual private server. Now, these are nothing but huge machines, and they host different VMs on those machines. So virtual machines. And they connect it to a database, and you can have a firewall with a private subnet with the database there itself. So what I mean by this is you're sharing, you're co-locating, you're hosted, you're sharing some things so that you don't have to pay the price for the entire hardware. So you don't have any upfront investment usually. You have complete control still. So you get the VMs, you get the entire desktop access. It's not very capital intensive, but long-term commitments are definitely required. So you got to tell them at least you have a year contract or something. Nowadays, few of them come up with, probably 15, 20 days or 1 month notice period or something, because they have to relocate that space to someone else. So it's all flexible, but definitely there's some commitment required. It does reduce the staff requirements because definitely there's fewer people managing this kind of a setup rather than the traditional one which we showed you earlier. Resources, compute, storage, and network building blocks available. Assembly is still required. assembly is still required. You still need to build things up, get your virtual servers in place and all that. Utilization resources may be underutilized, but you still pay for it. Yes, that is also true because you have multiple instances loaded up and you've already paid for them, and then you want to shut down one of them. You cannot do that because you're already under contract. So a lot of things are involved in this kind of a model. So when you want to release it, they have to take that instance, move it to something else. It's not automated, so it takes a couple of days or months probably to do that. To really create something. Performance issues may negatively impact the user base as in the traditional data center. Hardware provisioning required by vendor takes time, and yes, you need a new VM. You don't need all the services to be installed and configured, that is for sure, but definitely the provisioning it takes little time, not as much as the traditional data center, but definitely takes little time. It's not self-service, not totally self-service. It is not instantly scalable again. You just can't dynamically scale up, scale down. Fixing also takes time as in the traditional data center, as I explained to you. It is basically similar to the traditional data center, except that it is virtualized. And you co-locate and you host it somewhere else in third-party data center because you don't want to own the infrastructure. So the cloud. So now this is the data center, different type of data center, the cloud infrastructure. So you know the benefits of the cloud. You have rapid elasticity. You have the OpEx versus CapEx, highly scalable. You can choose your cloud hosting when load is unknown. You can test the scalability for applications, monitor system load, dynamically provision resources. You don't worry too much about the scale because you can on demand you can scale up and you can get it from a pool. So you can auto scale and you can use the cloud services, whatever the services the cloud provider is offering you. So it's one layer above the virtualization layer. So it makes things easier and easier to manage and stream to users. So in the cloud infrastructure, you have users connected. You have a edge router all inside the cloud. You have the firewall. You have all your servers inside the cloud network. You have an object store. You have a database. You can create virtual private nets. All this within the box of the cloud, all are virtualized. So basically, all these will run under some kind of a hardware below it. So what you see is the virtual environment. So over that, and you use those services. So you want to scale to web servers, you just request web servers, and the cloud provider will go through all their hardware servers and find out which virtual machine, which physical hardware there's space, and to allocate a virtual machine on that physical hardware. So you don't have to know where the physical hardware is also. So if you have, example, you have 100 machines and you request 100 physical machines and you have, say, each of them have got, say, 2 virtual machines on that. So you have totally 200 virtual machines and you are available. So now you're using 2 of them and you want third one. So the cloud provider will go and check all these 100 physical machines, which virtual machine is available, where there is space available, and to immediately spin up a new virtual machine on that specific hardware, and it's given to you. For you, it is all in one place, but actually all those 3 virtual machines can be residing in different hardware. So that's the beauty of the cloud. Virtualization, where you have to put it on the same hardware. So there's a very thin line between virtualization and the cloud. Cloud definitely uses virtualization. So the traditional versus the hosted versus the cloud. So very quickly, we already have seen this, but let's go through the differences. So traditional basically is bare metal. Hosted is bare metal plus virtualization. So you have a virtual environment there. And the cloud, it's virtualization and all the virtualization in the cloud. So it's a layer. So you have bare metal underneath, then you have the virtual layer over it, and then you have the cloud layer over it. Cloud also is a piece of software. So virtualization also is a piece of software, emulation software. So it is, the traditional data center is not designed for failure. If something fails, the hardware fails, the entire application goes down. In the hosted, not really designed for failure actually. So what that means is you have virtual machines. If it goes down, yes, you can spin up another virtual machine, but it definitely takes time. You go back to the vendor and say, I want another virtual machine because my previous one crashed. And the vendor will say, okay, let me see where there is space and where my virtual servers have got space, and then what kind of requirements do you have? All right, now let me try to get you a virtual machine. All this takes time. It takes a day or maybe 2, maybe a couple of hours. But for the cloud, it is designed for failure. You don't have to call the vendor. You just go onto your website, onto the cloud's console panel, whatever they give you, like for example, Amazon, OpSource, whatever they give you. request for a new resource, and there within minutes you have a new instance spin up. Also, you can automate all this process. If you have scripts to monitor your instances, and if something goes down, you can immediately spin up a new similar instance. You don't have to worry where it's going and which hardware it's placed. That is all taken care of by the cloud layer. Coming to flexibility, optimization, and scalability, traditional is pretty much inflexible because it's pretty static in nature. Downtime is definitely required. Hosted scalability, there is some scalability available, but not instance may not require reboots or something. As I was saying, you can scale in the hosted environment, but again, you need to call them and tell them to scale. In the traditional IT, you have to buy the hardware. Here, you don't have to buy the hardware. They will reallocate it in some other hardware, but it definitely takes time. It's not instant scalably. Not scalable instantly. The cloud is highly scalable. All resources are integrated with shared resource availability, so you can instantly request resources and scale. In the traditional, resources are 100% dedicated, so it's for you. It's in the hosted, it's flexible. Move a VPS to another VPS may not be quick and smooth, so you can move resources around and move the virtual servers, as I was saying, around. You can do, but it may not be very smooth. And the cloud is extremely flexible. Move instances around in different data centers. Like for example, Amazon's East Coast, US East, 1A, 1B, 1C, 1D. You can move them around any of those four. You can stop an instance and start it in another availability zone, which is nothing but another data center. There are ways even to stop an instance and start it in a different geographic location also. Like for example, US East, and you want to start it in US West. So the virtual machine actually gets migrated to US West. So there are ways to do it. It's not straightforward, but definitely you can do that too as well. Sharing. There are no shared resources in the traditional IT, traditional data center. It's all dedicated for you. In the hosted, you have processor, disk, memory, network, all shared. So you might experience some kind of performance issues or whatever. But the virtualization layer, if you use like VMware or something, it takes care of many things for you very seamlessly. So it sees that one user's performance if something happens, and it's basically a lot of load is coming onto one virtual machine. It doesn't affect the other one's performance as well. So the VMware does that virtual management very well. For the cloud, available resources include bandwidth, CPU usage, memory utilization. It is definitely shared, but very well managed, much better managed than the traditional, than the virtual data center, the hosted environment. So they manage it pretty good. Control, customization, and security. You have full control of a data center in a traditional data center. Hosted, you have full control of software components only with admin and root access. In the cloud, you have total control again. So in the cloud, you have control over the network, the resources, the storage, the firewall, you name it. You name all the services, you have total control. In the hosted environment, you only have control for your instance. Because remember one thing, the hosted environment is nothing but a virtual machine. They don't give you access to the whole network. They just give you access to the virtual machine, typically. But in the cloud, they give you access to the virtual machine, the whole storage, the network, the firewall. If you have a database service, the database, everything you get access to. So the traditional data center infrastructure, security, and high availability is very low. So the security and high availability is low, medium, and high. I know this is very controversial because in a traditional data center, anybody can walk in anytime. They can walk in anytime, and many data centers are not very secure. And the hosted environment, because it's shared, and you have your virtual machine shared with another user, they are very careful with this, and they make sure that you just don't come and walk in whenever you want. Cloud is extremely secure, extremely secure. Even the Amazon, for example, the Amazon employees are not allowed to walk into the data centers. So they cannot walk into an Amazon data center, although they're an Amazon employee. They have different levels of security. And for example, the Amazon Gov Cloud, it is still more secure. So you have to pass through a lot of security checks, credentials, the background checks. Everything is done before you walk into the Amazon Gov Cloud. which is only meant for government organizations and financial, basically all government organizations. So that's where the defense purposes, they use the GovCloud. So traditional IT, again, control panel varies depending on type of OS provider. You have different control panels, and there's half the things doesn't do all the things. So hosted images is a dedicated data center, a dedicated server. And as I said, the cloud, you can monitor everything, scalability, instances, storage, high availability, everything you can monitor and manage by yourself. So CapEx, it's very expensive, and a dedicated server requires significant upfront investment. Almost 10 times as much as a VPS, virtual private server, that is nothing but the hosted. So you require a lot of money to cash to buy the server every day. That's the initial investment. In the hosted model, it's cheaper since the server is shared. You have predictable billing, possible to exceed paid resources if available. So if you want to exceed it, if it's available, they'll give it to you. But suppose they run out of space, then they don't have space on the data center, they cannot give it to you. So that is a problem with it. And for example, you want to scale up or you want to add a load balancer, then you have to, and if they don't have the space on the same machine, then you have to add an external load balancer. So there's a lot of things we need to do there. So it's like kind of cheap, but it's not very cheap as well. But in the cloud, it's operational expenses. It's the cheapest up to the minute type of billing. There's a lot of contention in the cloud, could be expensive. There are certain cases it could turn out to be a little more expensive, but not all the cases. And for something like this, typical cases when you want to scale up, scale down, cloud is the cheapest, but not always. So you have up to the minute type of billing, you pay as you go, ideal for predictable traffic and resource usage. So unpredictable traffic, I'm sorry. So you have unpredictable traffic, in the daytime it goes high, and in the night if it goes low, you can just swing it up, scale it down, and you only pay for what time you have traffic on your website. That's the time where the cloud really becomes very cheap for you. So traditional data center is very capital intensive. Of course, you require more staff to maintain it, and we need people to manage always there. And hosted is not very capital intensive, as I was saying, and it reduces some amount of staff. And in the cloud, expenses are directly proportional to business operations. So you have business, you pay for the cloud. You don't have business, you want to scale down, you do not pay for the cloud. So you don't pay for you don't pay for for any resources, physical human resources to maintain that data center, because the vendor takes care of everything for you. So all that is removed from the cloud. So let's see a scenario about the cloud, traditional hosting and cloud hosting. I just put up a very simple web application, not to make it very complex. So you have an e-commerce web application. You have it built on Java, Tomcat, and MySQL, and you have high storage requirements for this application. You also have peaks and troughs. The website has spikes in the peak seasons. So December, application expected to scale up and scale down as required. Okay, so the peaks are in December, again in say February or March, it has to scale down back. That's the typical thing. The recovery time objective is half an hour, and recovery point objective is like 1 day. So the time when the server service goes down, they want it back up half an hour. And the data, what they want to recover is 1 day back, at least 1 day back. That's what the RTO and RPO mean. So RTO is the time, how much time they can afford downtime, and the recovery point objective, RPO, means how much data they can afford to lose. So here it is 1 day. So 1 day back, they can afford to lose. I mean, say 1 day's data, they don't mind losing. And you also have high requirements for analytics and log processing. So in a traditional data center hosting environment, this is how you will put up the whole thing, request for resources. You will vendor provisions the hardware and install and configure Tomcat, MySQL. If the application server load increases, you request for more. If the database load increases, we need to upgrade it. If the server goes down, then you need to fix it or request it. All this thing, whatever we discussed earlier, all this you have to do by yourself. That is the traditional hosting. This is how you, and you can see the two Tomcat nodes acting, and you have a load balancer there, and you have a SAN, and replication is done over the SAN, and high storage requirements is managed over the SAN, and you have a MySQL master and slave under a firewall, which is a subnet, and so it's not exposed to the public. The typical scenario of a traditional hosting. In the cloud hosting IaaS, I'm not going for the virtual private hosting because it's the same like the traditional hosting, except they're virtual private servers. So the cloud hosting, you do all this request for resources and provision them as required, no vendor involvement, it's all self-service. You configure your compute storage and network, you install, configure Tomcat, MySQL, and create images as backups. In fact, you have many of the cloud vendors have got big images. So Amazon calls them Amazon machine images, where you have everything configured. Tomcat, MySQL servers, all configured as image files. You just have to choose the respective image file and then fire it up. It's just a matter of few minutes. Then you configure firewall rules. It's very simple, straightforward. All software done, driven. Request for other services like CDN as required to get them instantly. If you want a content delivery network, you want to distribute your file system, you can do that with CDN if the cloud provider shows you. I've taken this specific example for Amazon cloud just to show you, but you can do it pretty much any cloud if they support that specific service. If the load increases, you request for another Tomcat server instantly and add to the cluster. So use auto scaling if required. So if something goes down, you just add it. It's a minute. You can just add it. And you can also provision new instances instantly. If all is done correctly, it should not take more than a day to do all this in configuration. And if you have log processing, use log processing to be done. You can do it with instances, or you can use something called as Hadoop, Elastic MapReduce, which Amazon offers. And scale up and scale down. So you can use Elastic MapReduce or build your own cluster, Apache Hadoop cluster on the cloud itself, where you can scale resources and instances up and down. So you can see the cloud network. You have a node instance, public IP, and you have an elastic load balancer, which is the software load balancer, then which is controlling this two instances. Then you have a private subnet, which is a virtual private cloud in Amazon's terms, and you put both the MySQL server under a private IP and you replicate them with a master slave. So these two are instances basically. So totally you have 1, 2, 3, 4 instances running in the Amazon public cloud. The 2 MySQL instances are basically privately hosted. So it's basically on the Amazon cloud, but it's on a virtual private network, which means we don't have public IPs. It's not exposed. And the ports are only open to the Tomcat worker nodes. That's it. Basically, because it's internal, it is not a problem. So all the ports, the firewall configuration basically will read and say all the ports for these 2 MySQL servers are closed from external public. So nobody can access these servers. If you want to access these servers, you have to go through the Tomcat servers or some kind of a gateway or something. So the elastic load balancer manages the load around, and you have the firewall typically. This is the typical scenario how it would be on Amazon's public cloud. And they use all the services like cloud services, whatever are there available on Amazon. Few of them are listed only. So the cloud hosting benefits, let's see what are the benefits. It's very easy to use, quickly and securely host your applications. Securely, yes, very securely you can host your application, data center security, application security, because everybody talks about cloud security, security, security. So these cloud guys have gone ahead and enhanced the security and beefed it up so much that it's very, very difficult to actually say that your data is not secure. In fact, they find that your traditional IT shops are more unsecure than the cloud, because the cloud, they built it and focused on security after a lot of people stopped using the cloud and started refraining from the cloud because of security issues. So, but now it is very secure. It's very easy to use. Everything is self-service. You are also very flexible. You can own your OS, programming language, the web platform, database, services. You receive virtual environment, lets you load the software and services. So basically you get the entire virtual environment to you. It's like a virtual network totally given to you, where you have your machines, you have your network, you have your storage, you have everything available at your disposal. You click and drag, drop what you want, and then select and say, this is what I want, configure it, and say you're up and running. That's what it's very, very flexible. It's very cost effective. And most of the cases, it's very cost effective for the cloud, because you only pay when you use it. Otherwise, you don't pay for it. So there are no long-term contracts, upfront commitments, and anything. Of course, Amazon has got kind of reserved instances where you pay lesser cost when you pay kind of as an upfront investment. That is a different kind of a model they're giving you, but the basic cloud concept is basically pay as you go. It's very reliable. You can take advantage of cloud providers, scalable, reliable, and secure global computing infrastructure. Of course, if you have a massive infrastructure like Amazon or Rackspace, Azure also is a very good cloud. You can make use of the infrastructure and scale up. It's very reliable. Scalability and high performance. Definitely, as I said, you can scale up. You have high performance. You can scale up and down as per the demand when you want, provided. Again, the scale is limited to the cloud's infrastructure, but the cloud infrastructure is spread across multiple machines on a data center, across data centers too. So you typically end up having a lot of resources available. Security, as I said, cloud utilize end-to-end security approach to harden your physical infrastructure and software measures. Think of it as a traditional data center who have enhanced their security. Since it's all virtualized, a traditional data center has some security. The cloud data center also is a traditional data center which has all those security measures in place. And they have all the certifications in place. Plus, they have given additional security over that layer. They even secure the data transfers, data transfer over the wire, at rest. All these security measures have been taken care. They're giving you features for it. At least most clouds have done that. So now coming, like, what app should be put on the cloud? What do you think about the application should be put on the cloud? So web-facing applications should definitely be put on the cloud. With the geographical reach, global mobile workforce, all these kind of applications which hit peaks and process times where load is not constant, dynamically scale up and scale down. These are the applications. Big data kind of applications like huge log processing, analytics, recommendations engine, batch processing, all these kind of applications. You definitely have to pay a lot of money if you have to host it on a traditional data center. So this is where the cloud is useful. For example, log processing, you want to crunch a terabyte of log. You can do it in a traditional data center. You have to have, say, 10, 15 machines to do it. Versus the cloud, you go and request those 10 resources, 10 machines, finish the log crunching, say 20 machines, you want to put 20, 30, 40 machines, finish the crunching in an hour's time, and you can get all the results back. So in the medical sector and all these financial sectors and a lot of places they use this. For example, Netflix uses a lot of log crunching. It uses a lot of streaming. When they want to stream huge movies, when they want to encode movies, they do use the cloud for that. And they only pay for the time they use that. Storage. Dynamic storage requirements, archiving, huge storage needs. It's not a good idea keeping it in a data center and paying a lot of money for the SAN. And when the data size increases and it runs out of space, you got to buy a new box, attach it, and you pay for that box, and you pay for the time to monitor that box, monitor the sandbox. So all this costs money. So this is where you have to put some things on the cloud. High availability, business continuity, and disaster recovery. So as I was explaining to you, you can dynamically add and remove resources when you want. And your disaster recovery, your RPO, RTO, all come down drastically because you can do everything on the fly. Streaming, audio, video, training, YouTube, you take all these, Vimeo, all these sites, they're all cloud driven. So when you want to stream to customers, you have to have a cluster of machines back at the back. And you need not be streaming all the time 24/7. Maybe Vimeo and YouTube are very busy sites, but the other sites, sometimes your traffic goes down. So you need to scale down. You cannot have these 100, 200 machines running and just doing nothing. So as the user base increases and the streaming increases, you keep adding nodes to your cluster. So that's where streaming can be used. QA, dev and test. This is a very big environment where now people are using it for the cloud. You have the application to be tested on multiple operating systems, multiple versions of the application server, multiple databases and their versions. How is all this done on a traditional environment? You keep going to the systems department, okay, create a machine for me, do this, do that, and they keep doing it for you. And you typically end up, you cannot test it in all the environments. But in the cloud, you can request these instances instantly on the cloud, load your application in different environments, do the testing, and then stop there. So you don't pay for that. SaaS applications. When you want to build software as a service application where you want to distribute the application to multiple different users of yours, and those users can distribute to their users. So this kind of applications definitely need the cloud. And one of them we have already seen is social media websites are typical candidates for the cloud. Typically, I mean, these are not the only candidates, but they are typical candidates for the cloud. So any kind of social media, you will definitely want to consider the cloud to do this. So let's go through some case studies. A radio service provider. We have actually hosted 15 plus applications to the AWS cloud. They typically, the reason what they said was high availability and scalability. They wanted instant scale. So security provided virtual private cloud. We have VPN and firewall rules built in. We have dynamically load balancing. It load balances all their servers and scales up, scales down. We have all the data. There are a lot of images and videos and audios and all sorts of data. We have distributed it over a CDN. We have a huge backup repository which stores all these backups, all the backups onto S3. And we also have business continuity in DR setup. So one of the servers go down, the other server picks it up immediately. If the first server which goes down becomes a slave. So it's all built in basically. So it's kind of a typical DR environment we have built up, and there actually recovery time and recovery point objective is around half an hour to 1 hour. That's something in that range. In fact, not even half an hour to 1 hour, it's a couple of minutes. So 15 minutes to half an hour, something like that. But we just kept it half an hour to 1 hour. So they're pretty good with it, and they're doing well, and their ROI has increased a lot. Because when they want to run reports, they spin up a cluster of machines with EMR and Elastic MapReduce. They give the query, and they get the results very, very fast. So according to them, their ROI has improved. So we have a media service provider where it's like a YouTube site I was talking about. Where the basic thing was the application scalability, growing infrastructure demands, and availability. So they wanted highly scalable infrastructure. So we built the whole solution on EC2. We used S3 as the storage platform. We used the virtual private cloud for the cloud thing. Dynamic load balancing, we scale up and scale down using the ELB and Elastic Load Balancing and auto scaling APIs. The content is distributed over a CDN because it's a lot of videos and a lot of encoding has to be done. And the encoding of videos have to be done. It's done with Elastic MapReduce, clusters of Elastic MapReduce to crunch these videos and convert the videos, because the application basically allows users to upload their own videos. It's just like YouTube. It allows users to upload their videos, and you can go up on the site and record a video and just upload it. And then you can take that video, edit it, and carve out a lot of things and make it context sensitive. There's a lot of business logic built up. So we had a lot of encoding has to be done there, converting from one format to another format. We use the Elastic MapReduce for that. We have CloudWatch to monitor its metrics. We have email service, simple email service for emailing, simple queue service for queuing all the records which come in. Any requests coming in for users are queued into the simple queue service. And they have to fetch from there, and the crunching starts. And it's near instant, but it's not exactly instantly. You cannot get your video, but it's kind of instant. Say half an hour, depending on the kind of how long the video is. So we allow up to 2-3 hours, I believe, 3 hours or something. So if it is like 1, 2, 3 gigabytes or something, it will take a little time, but it definitely it does it on the spot. The portal currently serves on 200 clients and over 10,000 videos streamed online. So they're increasing, dynamically scaling up, and that's the beauty of the whole thing. They scale up without any problem. No issues on scaling up because of the Amazon cloud. So it is another for a medical company. They have a requirement for loading their servers with high availability, load balancing, auto scaling, and Elastic MapReduce for crunching through their log files, crunching their medical records, patient records. They have like, millions of them. So they wanted to crunch this. So we used Elastic MapReduce to do this. They have totally DR set up. And I think, I'm not sure, they run around 20-25 servers currently managing all this. And Elastic Map cluster is different. The MapReduce cluster is different, which manages all the crunching of logs and patient information. So we use virtual private cloud, similar to other things, and we use the queue for queuing the requests and notifications for notifying different users about what is happening. So currently serve more than 10,000 users. So Smart Price Cloud Services. Very quickly, we have 4 major categories: applications, integration, infrastructure, and management. in the applications, we have application migration, so we migrate the applications from traditional IT shops and traditional applications into legacy applications, basically into the cloud. So we don't rewrite your applications. We build over that application. We build a service layer over it. We try to see how much can we rip off and how much can we actually cloud enable. We try to reuse the maximum as possible. Application modernization. You have an old application like in Power Builder, Fox Pro, VB, Visual Basic, you name it. We take that legacy application, we migrate it to .NET or Java, whatever platform you choose, and we cloud enable that application. So in building that application, we cloud enable it, building the new application. Migrating to SaaS, we take a traditional web app and we build a layer of SaaS around it. I'll be giving another webinar very quickly in the near future about how to SaaS enable your application, the do's and don'ts, and what are the points you should consider. So this SaaS thing, we build that layer. We can use Salesforce kind of platforms, or we can build a custom SaaS layer just to suit your needs. So inter-cloud migration, we migrate clouds from one cloud to another cloud over the, say, Amazon to GoGrid or OpSource or Azure. Why? Some benefits sometimes. We have seen certain clouds don't provide some certain features. We have done a couple of migrations, so we provide that service. Cloud strategy consulting, we come in, we get your company, we check out your environment, we suggest the best models for the cloud, what should be cloud enabled, what should not be cloud enabled. These kind of things, we give you a report and then you choose what you want. Integration, cloud integration, because we have multiple clouds, different places, some in data is there in your data center, some in your local infrastructure, some in the cloud. Some customers do have this. So we provide integration methods where you can integrate it. We're using cast iron, IBM cast iron or Dell's Boomi kind of integration platform. There are multiple integration platforms, but we use IBM's cast iron to do this. It's very robust. In the infrastructure side, we have private, public, hybrid clouds. We can come and build a public cloud for you, or build a private or a hybrid cloud using VMware's, Zen, KVM, any of these cloud.com's infrastructure, Eucalyptus, private cloud, anything. We have got experience in all that. So cloud infrastructure deployments, we do desktop and server virtualizations also. We actually provide your data center as a service, kind of an offering where you have all your resources at your disposal, so you can use whenever you want. Backup, disaster recovery, and continuity services, and also we have Smart Price Cloud Backup, which backs up data and does typical cloud-based backup. That's a small product from ZSL. And the management, we have cloud-based managed services. We manage the entire cloud for you. We give you the billing, we give you the usage patterns, we give you how you can reduce your money, reduce your costs, if underutilized resources. All this can be done in the cloud-based managed services. And Smart Price Cloud Manager is a provisioning and orchestration and configuration management tool. It's a total management software built by ZSL for our customers for managing the cloud very easily. It basically, typical cloud-based management software is a little complex, difficult, you need to be technical. The Smart Price Cloud Manager is more business-driven, so it is very simple to use. So these are the partnerships with multiple cloud providers. Okay, Rackspace is not there, but Rackspace also is a partner. So these are all Amazon, IBM, SaaSGrid, Azure, Red Hat, Oracle, name them, OpSource, all of them, Google, all of them are our partners. So that's it from my side for moving to the cloud, how things to consider. I'm sure you might have some questions. I'll just take some questions. You're running out of time. So
thank you, Naveen. So now the Q&A session is open. So if you have any questions, please enter it into the chat window that's on the right-hand side of your screen. Okay, you can also post your questions or write your questions to info@zslinc.com, or you can call us at any time at 732-549-9770. I would like to thank everyone for joining us on today's webinar. This webinar will be posted on ZSL's TV and webinar page. Have a great day. Thank you all.
Thank you.